everybody. My name is Victor. Um, Data science is not something new. It has been around for many, many years, right? We all know this. Have you guys know Abraham Wald? So Wald was a mathematician working during the Second World War, and he saved many, many lives using data analysis, right? It's really interesting because we don't know the name, and this guy has been really important, okay? So Abraham Wald was asked the following question, okay? What areas of a plane do I need to reinforce so I can actually protect my pilots and the planes coming back from the war zone, right? So I want to make sure that I have more planes coming back from the war zone. What areas should I reinforce of the plane, okay? Let's look at the data. You know, looking at the data, you see the red dots. The red dots shows where the bullet holes were on the planes coming back from the war zone, okay? So your brain's probably saying now, oh, let's just reinforce the areas where we see most bullets, right? But that's a bit counterintuitive. So let's think about this in detail now. If the planes are coming back from the war zone, that means that these areas can actually sustain damage from bullets. And we need to reinforce every single other area that is not showing bullet, holes. So this is data science at its best, okay? It is proper data science. The main difference between today and 50 years ago is technology. So technology has changed quite a lot. I'll give you a quick example. Processing power. So now we have the ability to process loads and loads of data, okay? So for example, look at your pocket. You have an iPhone, you have an Android. This has the processing capability that is incredible. If we wanted to develop the processing capability we have in the iPhone today, in the 50s, it would take 1.5% or 1.5 of the world's GDP. It would consume 30% of the world's energy just to keep it running. And it would require a hardware room of 3 kilometers per 100 stories, right? So this is how, and everything now is in our pocket. So that's fantastic, right? So it's a massive, massive achievement. So yeah, we're going from the 2019 to 1950, and that's the kind of the comparison that we have. Now, how do we do this? How do we do data science, on the fly? In Thales, we have a 4-step process. It's very simple, really. Well, the first thing that we do, we look into data engineering and the data preparation, right? So we're trying to answer a few questions. Have we seen this data before? Is it structured in a way that we can use it? Is it, have we applied algorithms to this before? So by answering these questions, we can actually prepare ourselves to move to the next step, right? So once we answer these questions, we move to testing existing algorithms. So Thales has prepared over 56 research notes only on predictive maintenance over the last 2 years. So there's a lot of research, a lot of existing algorithms and knowledge that we can actually use to process and play with that data, okay? So once we test the existing algorithms, what we can do, we can actually move to an exploratory piece of work. So we never stop learning in data science, right? So you have to apply generic algorithms so you can actually see if there's new insights coming from the data. I'll give you an example. We were working with axle counters for the past 2 years now. We just realized that some of the warnings, some of the data that we were collecting, it was bringing noise to our prediction. So we had to find a way of filtering out that noise, which was discovered via exploratory work. So, you go through the entire process, you prepare your data, you test your existing algorithms, you do some exploration work, and finally you do the reporting, right? So once you do the reporting, it's typically a dashboard, it's typically the tool by itself that you can go and play with it, okay? So one of the things you're going to notice, there is a feedback loop in each one of these sessions because we want to kind of learn from each step and move on. The key thing for me is that this is not difficult at all, right? It feels like data science is very complicated, but it's not. It's something that's very, I wouldn't say simple, but it's not as difficult as people pose, right? I'll give you, again, a use case of a successful application of data science. We have one of the customers in Asia they were doing manual surveys, right? So they had people counting passengers boarding and leaving the train, okay? So they would have people there standing by the door of the train, just counting passengers, right? Imagine just doing a quick math. If you have 2 surveyors per door, per train door, and you have 10 doors, you have 20 surveyors per platform. If you have 2 platforms per station, you have 40 people just counting passengers coming and going, which is probably one of the most boring jobs in the world, okay? If you're doing that for 10 stations, you have 400 people just deploying, checking the number of passengers. If you have that for the entire week, that's 7 days of 400 people counting passengers coming and going, which is, an extremely difficult, cumbersome job. We took that and we streamlined that capability into just collecting the ticketing data that we have, and we can do the same job that they were doing, taking 4 weeks in 15 minutes. So that's an example of how data science can effectively, automate some of the processes that we have. Okay, so my challenge to you guys is, where is your data? You have a lot of insights waiting to be discovered in your infrastructure, right? And again, this is not difficult. All we need to do is go through the 4 steps process: data preparation, testing existing algorithms, testing new algorithms, and reporting that. So it's very simple, right? And in the railway, we are in a very kind of a good and bad news kind of situation. We are falling a little bit behind, to be honest, but other verticals have a lot of knowledge that we can extract. Oil and gas, telecoms, power, they all have a lot of information, a lot of existing knowledge that we can extract from these systems, right? And we just need to reuse that. So I'll give you back a challenge. Where is your data? What are you doing with it? And if you want, we can have a look. Thank you very much.